All right, good afternoon, everybody. The time that I'm showing here is officially 12 o'clock. It's Wednesday, April 26th. This is our second installment of our Coastal Industry Week webinar series. Today we got Leigh Sharp, one of our scientists at our Lafayette regional office here at CPRA, is going to present to you on the CRMS program. Before I kick it over to her, just wanted to go over a couple of housekeeping items, not really a whole lot. In the event of any questions, feel free to type them into the chat box, and I will be monitoring the chat box throughout the course of the presentation. And we'll try and field them as necessary. And I believe there should be some time towards the end to answer any specific questions as needed. This meeting is being recorded as well. This event, in addition to Rudy Semino's webinar that was held yesterday and the future webinars to occur, plus the partner-led coastal industry briefing that was held yesterday and the CPRA-led industry briefing, are all being recorded, and those will all be made available via CPRA email blast out sometime later this week. I guess without further ado, I want to kick it over to Leigh and tell everyone thanks for coming today, and thanks for being a part of Coastal Industry Week here at CPRA. Over to you, Leigh.
All right. Thanks, Jack. Can you hear me? Everything's good?
I can hear you and I can see your slides.
Okay, cool. Well, thanks. Yep, I'm Leigh Sharp. I'm in CPRA's Lafayette regional office, where I manage scientific aspects of the CRMS program, in addition to coast restoration monitoring in the western part of the state. So, let's see. All right, quickly about CRMS, and then we're going to get into the data. We've got 389 sites where we're collecting everything from hydrology and vertical accretion, elevation change, land change. It's basically collecting all of the same stuff from every site. So these are some example pictures of what the sites look like. The boardwalks are built around rod surface elevation tables. And so there's a lot of that, and then vegetation data and hydrology data. It's all publicly available. If it's easy to get to, you should be using it. If you're a coastal practitioner in Louisiana and you're not using CRMS, I don't know what's wrong with you, but it's there and it should be easy to get. So the recent news is about sea level rise and sea level acceleration in the Gulf of Mexico, and how it's faster than the rest of the globe and how it's getting hotter here. CRMS sites definitely see all of that sea level rise, and so we're going to kind of get into the initial response of that. Then, the news was a little depressing in that they're now relating it to the AMOC and to a shutdown of the AMOC, and that having an effect on Gulf of Mexico sea level and water temperature. I'm not surprised. The loop current does seem to be a big feature. I've been watching it shed eddies for some time now. They're down at the bottom right. You can see the month of April. It should be animating. I don't think it is, but it's already spit one. It's trying to spit another. It just keeps shedding big chunks of the current into the Western Gulf. So I think it's high and going to stay high, and we can anticipate more of the same. So it's good we can get an early look at the effects of this initial rise. So this is Galveston data. And then to the right is several NOAA stations, annual mean water level, and the CRMS coastwide mean in blue. And that's to capture that CRMS sites see all of that, the sea level rise captured at the NOAA stations. And then if you look at how much, there's at least half a foot in this recent acceleration. And we're a good 1.5 feet above the 1960s mean. And at least over here, a lot of the infrastructure was built in the 1960s. So it's kind of expired. And that's a lot of the problems that we see are related to that sea level so much higher, and our structures just don't work the way they used to. So looking at the CRMS data, water level went up. So you can see it in the water level data. These charts are by marsh type. So swamp is blue and salt marsh is the darkest red. So in general, water elevation is highest in the swamps and lowest in the salt marsh. The increase is the greatest in swamps on the deltaic plain and fresh marsh on the Chenier Plain. Chenier Plain went up at least half a foot, and marshes on the deltaic plain at least about a third of a foot. And so, it's an issue coastwide, and the more inland and fresher marsh types see it the worst. I would note that, like here, the difference between the Chenier and deltaic plain in the intermediate and brackish marsh types captures the fact that a lot of those marsh types are impounded on the Chenier Plain, so that they also see the effect of trapped water. And then if we look at flooding, to the right, that's the impact to flooding. This is depth, but it would also affect duration of flooding or inundation of the marsh. The inundation depth increased by at least 3/10 in all marsh types on the Chenier Plain and around 7/10 in fresh marsh. Deltaic plain went up at least 2/10 of a foot in all marsh types and 7/10 in swamps. You do get some flood relief in droughts, in 2018 drought and in the 2022 drought. If you look at the Chenier Plain inundation chart, you can see that the brackish and intermediate marsh only gets close to marsh level in a drought. Otherwise, it's persistently flooded. So that's a problem. Salinity initially went down. It was a surprise to me that when sea level went up, salinity went down. But those were also kind of high rainfall years. 2016, 17 were wet years. And so it's not as though the ocean found an empty bowl to just fill up with salt water. It was flooded, and what it meant was water just couldn't get out. And so we've got trapped rainwater, freshening marshes as the initial result of sea level rise. But you can see 2022 drought had an effect, and we are kind of getting back up to some higher salinities in on the Chenier Plain. On the deltaic plain, those are open tidal sites. The impact isn't as severe, but there is a general freshening trend. I gotta imagine that's has to do with river years, high river, low river, that sort of thing. But and then of course you see the most freshening in the more saline marsh types, which makes sense. If we look at the map of sea level rise and kind of water level change here, I've got 2014 and 2021. Of course, the hotter colors are higher, and so I've ramped the entire range of values in the data set. And so, you can see that the tidal marsh was always the lowest. It's still the lowest, but it's a good several tenths of a foot higher. And then the inland area is really stacked. The Atchafalaya Basin stacks, the impoundments hold water. And basically, if you're an outlier on that 2021 map, if you're a dark blue dot in a sea of red, there's some sort of management, or I suspect you're pumping. Some of them are, I think, actually sites that are pumped or managed, or on the Chenier Plain have some tidal connectivity or connected to the lower Mermentau River and do benefit from tidal drainage. Otherwise, they're all pretty high. And so if you look at basin means, that chart is the difference between kind of the minimum in the data set, 2011 and 2021, and then the data point right before the acceleration in 2014. And you can see that the Mermentau and the Mississippi River are up the most, but every basin has gone up. Let's see. So I'm going to get into land change data and elevation change data and vegetation data. They gave me an hour, so we're doing it. Land change, what I'm using here are the CRMS site kilometer square classifications that USGS performs from the coastwide flights. So those are sub-meter and at the CRM site level. So that top map is kind of where we started, how much land each site had within the kilometer in 2005. And then the bottom one is the percent of that top map that was still there in 2018. And doing it that way really kind of captures that the more fragmented parts of the coast have continued to lose land. And then there's kind of an emerging hotspot in the western part of the state that's, kind of emerging land loss. And then you do have some land gain. The deltaic plain, the delta, the Mississippi River Delta is gaining land, and some of the inland sites have been gaining land over this time frame. We have a 2021 product that's coming out soon. Be an update to this, and I expect some additional land loss and some differences there. Surface elevation change rates are still positive. If you've heard me speak on any of this before, one of the most interesting things I think is that throughout, since inception, those rates have generally been positive, even on the deltaic plain, even in the areas where we're losing land. And that's still the case. 80% of the Chenier Plain sites and 90% of the deltaic plain sites have positive trajectories. But if you look at how many are, up around a centimeter a year, which is, what sea level rise is apparently, only 7% of the Chenier Plain and 29% of the deltaic plain reach that threshold. There are regional differences. The difference between the Chenier Plain and the deltaic plain is significant. It's twice, elevation gain is twice as high on the deltaic plain as it is on the Chenier Plain. And then even if you exclude the Mississippi River and the Atchafalaya deltas, it's still almost twice as high. So it's a thing. The differences between the regional differences are going to be related to river influence and tidal deposition, and then the limitations of the Chenier Plain as far as impoundments and not receiving tidal deposition, and a lot of it coming from primary production, and now mat detachment. We're going to get into that because we're starting to see a lot of mat detachment related to persistent flooding, and even in more saline marsh types on the Chenier Plain, which is alarming to me. Basin scale differences. The deltas are gaining elevation significantly faster than all of the other basins. If you kind of look at what's going on. And so I've been thinking about it as in the framework of where in the coast do you also see delta scale elevation gain? Because that tells you something's going on. You know what's going on in the delta, but when a non-deltaic marsh begins to behave that way, what happened? And so we're going to look at an example of a site that had delta scale elevation gain due to erosion. And then the other outliers would be marsh creation, PO 104 nourished a site, and it had really high, now it has a really high elevation change rate. And then detached floating marshes can start to look that way. So we're going to get into those. Also, we got to deal with shallow expansion and mat detachment. As sea level has risen and we've seen more elevation gain, it appears that the mechanism, particularly in some Chenier Plain marshes, is gained from within the mat. So by that I mean, you expect surface deposition, and we have this value that we like to calculate that's the difference between accretion and elevation change, and we tend to call that shallow subsidence. But sometimes there is more elevation gain than the accretion would explain, and that would be shallow expansion. And so both of those things are happening within the root zone. And then this histogram captures the fact that the frequency of those values of shallow expansion are increasing as sea level has risen. And so you see, since 2017, there's a lot more. I'm just using the sites that had at least 15 millimeters of shallow expansion to kind of avoid the noise. So this is just those. And so about 9% of the observations have some shallow expansion in them at this point. It's mostly intermediate marsh, but we do see it in more saline marsh types and brackish marsh and in salt marsh, which is alarming to me. We only deployed this equipment in the marshes that were thought to be attached when we set up this network in 2005, 2006. And so some we've watched them detach, and then some that we thought were attached all along have actually become attached, like Davis Pond sites. And so there's a little bit of everything going on. But I guess I just want you to know that elevation gain from the mat is possible, particularly in response to prolonged flooding. And it's baked into those values if you're using CRMS elevation change data. So this one is the number of observations of shallow expansion beyond 15 millimeters at a site. And so if it didn't have any, those are white. I grayed out the 1s and 2s. Some of it is just variability, but where you've got dozens of observations, those are floating marshes. Those have most likely fully detached, and that's how they move is with the water. And then when you have a few, I think it's pointing to an emerging trend that, these sites, after they've been flooded for a long time, do find a way to kind of gain elevation, but it's coming from within the mat and probably at expense of soil strength. That it seems more erodible if it's stretched or floating. And at least one site that we completely lost, that's where we've seen conversion to open water at the boardwalk, had begun to float, 545, which I've highlighted there. From about 2017, the data indicated that there was some expansion going on. And then in 2019, Hurricane Barry removed it. So I'm suggesting that they're related. So I'm going to get into some examples. We've got several things going on with elevation change and land change and relationships between, high elevation gain and land loss in the lower deltaic plain. You've got elevation loss and land loss in some parts, and then you've got high elevation gain and land gain, which I'd call delta formation. And then kind of looking at some of the destabilization on the Chenier Plain. So starting with that lower Barataria site, I'm highlighting CRMS 174, which was removed by Hurricane Barry in 2019. But before that, it was constructed in 2005, about 40 feet from the edge. That's that top left picture. And that would be kind of around that first data point on this surface elevation change chart that I'm featuring. And then by 2016, which I've got it kind of circled and in orange, and I've also highlighted the borders of those pictures in the same color. By then, there was so much deposition that the boardwalk had been buried, and the rod itself, the collar, was being buried, and we needed to extend it, and that was new. And so we extended it. That bottom photo is a brand new extended collar so that we could keep measuring. And then by 2019, spring 2019, that top right picture, at the high elevation site, the double-decker boardwalk, there's a shrub in the plot. The vegetation is perfectly healthy, but it was removed by Hurricane Barry. And then that's our final measure, our final photo of it right there at the bottom, right before we had to remove the site because it had become a navigation hazard. So that's what happened at that site that we lost. And if you look at its neighbors, there's lots of sites, and these are all lower Barataria surface elevation trajectories. And they kind of have a similar thing going on where you see elevation gain trend, some of them pretty high, an acceleration in elevation gain, and then conceivably land loss is what's coming. And so I've started to, you can flip through just the surface elevation charts, which you can download as a whole big bulk batch on the CRMS website, and flip through these and kind of see where there could potentially be issues just related to the edge getting closer and deposition associated with that. But no, there is going to be some noise in there from the Hurricane Ida deposition. What wasn't removed from Hurricane Ida did see a pretty good deposition event. So through 2021, it's easier to sort that out. If you include 2022 data, that could be an Ida deposition in addition. And so there's a picture of one of these, the one on the top right, that's not the site that just eroded, but the site that will probably erode next. That's CRMS 178. You can see the rod itself is in the water. It saw a lot of deposition while the rod got in the water, but you know, it's just a matter of hurricane next will be enough energy to remove the rest of that marsh, and that'll be an open water site too. So I think that's kind of what's going on in lower Barataria. So we're switching to 2 now. So it's on this little map at the bottom, switching over to lower Terrebonne, a site that was losing elevation and land. And so here's what CRMS 302 looks like. We start the pictures in 2012, and this time we're just going to look at like pictures of the R set. Like we take that picture every time we take a measurement, and they become really, really valuable in situations like these. And so the 2012 picture, it had already gained some elevation and was kind of on the edge. And you can see the rod in the bottom left in 2012. 2014, that orange data point, it's buried in shell hash. You know, it's the surface is almost up to the collar. It's a you know, you can it's a very stable surface at that point. 2015 would be the next data point. That's damaged vegetation. You can see it's kind of starting to get torn up. By that fall, it was in open water, shallow open water, but in open water, the vegetation was dead. 2016, and it lost a bunch of elevation at that point, right? It holds its elevation until, you know, it gets on the erosive side of the removal side of erosion, and then it loses a lot of elevation. And so 2016, it was in open water, and it's that picture to the right, it's in open water and it's still relatively calm. Like we're able to get the bottom side, the back side of elevation change in some of those lower Terrebonne marshes, because they just tend to last longer. You know, it doesn't, I don't know if they're lower energy or what, but eventually 2017 tropical storm Cindy took it out, and we did have to pull it at that point because the rod was destabilized. But we'll keep measuring bottom even after the vegetation is gone until the rod itself does destabilize. So that's what's happening there. It's friends and neighbors that are kind of doing the same thing. You know, I've kind of pulled in the charts for all of the red dots in lower Terrebonne, and you kind of see a similar trend. You know, there's elevation gain and then loss. One of them, 376, is all loss, but I'm guessing we just missed the gain. And then, but you still also see the similar thing to lower Barataria, where trajectories are positive and, you know, they accelerate towards the end. And so I think it's the same thing. I think it's just erosion at different paces. And so, like, together, the network captures all of the different phases of these processes. You know, you've got it where it's just starting, you've got them where they're about to be removed. And I think that's really the power of this approach. So we're switching to 3. 3 was this one. It was this Mississippi Delta one. You can see on that bottom map. We're going to look at one of the highest elevation gain sites there. This is CRMS 2627. So this one starts out, they go through this process of, it'll just be open water, shallow open water with some new sand deposit, and then that gets vegetated, and then it'll be some new sand deposit. So that's those ones on the left capture slugs of sediment. It gets vegetated and then wiped clean and then vegetated again. By 2016, that one had completely buried the boardwalk, and it needed a double-decker boardwalk, and it needed its rod to be extended, which we did. And so it continues through those cycles of deposition, kind of wipes the slate clean and then starts over. But there's a picture of it in 2021. The vegetation's a bit thinner, and it's covered in a floating aquatics, which do smother the vegetation in some of these deltaic sites. And then you may see some elevation loss or even land loss for a period and then there'll be land gain and elevation gain elsewhere. So I would argue that the deltaic plain sites also capture the range of processes, and those are good. Those are similar to diversions, and we can get a good feel for what's going on at diversions, or what diversions might do, by looking at all of the Mississippi Delta. So, like other sites in the Delta are also gaining elevation and land. Some of them on the edge are eroding. They build and then erode and build and then erode. The Atchafalaya Delta, that top one that's kind of to the left, it's slower. It was building land slower, or building elevation slower, and then got a big slug from Hurricane Barry. So the rates will be about the same, but the processes are a little bit different. Switching west, and you can't see it here, but we're going to the Calcasieu-Sabine Basin in the East Mud Lake impoundment, which is Lower Calcasieu Lake, if you're familiar with the CS 20, if you speak CPRA. So this site is inside an impoundment that was well managed and had plenty of vegetation, and is now a detached floating salt marsh, which has to be the worst case if you're a salt marsh. So in pictures, you got 2008, that's kind of at the beginning. It was an attached brackish marsh. You see increase in flooding and subsequent deterioration starting about 2016. Talking to the land manager, he said that when sea level went up, it's just coming over his levees. It's higher than the CS 20 levees, and so it's pouring in from a couple of sides, and that infrastructure is no longer sufficient to manage the marsh the way that they had historically. And so all of those observations in the red box have shallow expansion indicated in the data. You can tell from the data that there was more elevation gain than there was accretion, but it's a salt marsh. So I don't know, that's new. I never heard of a floating salt marsh, and there's more elevation gain that if you just look at the number, if you just take the rate, you could say, this site's doing great, it's building all sorts of elevation. But in reality, it's a floating salt marsh. And so you got to kind of put it all together when you use these data. To the right is the land change chart for that site. And you can kind of see that it was doing pretty good till about 2016, and then fell off. And so it's definitely related to the sea level acceleration. And I would argue that a floating salt marsh is hurricane bait. I mean, elevation gain is great, and that it is able to maintain vegetation while it's persistently flooded, it is great. But if it's detached when you get a big storm surge, I'm concerned that it just gets carried off. So sites on the Chenier Plain, and specifically in Calcasieu-Sabine Basin, that look a whole lot like 672 are featured to the right. There's a good bit of it, and I was surprised that brackish marshes that once held cows are now kind of floatant. But It's a thing. So, and I guess I would argue that it points to a need for hydrologic restoration in that part of the coast. You know, we like to do marsh creation, and we can do marsh creation, but we're going to need to build it higher and higher in those impounded areas, and may need to think about managing water level as well as best we can. Impacts to vegetation. So now, since it's perpetually inundated, particularly Chenier Plain, and you only see, it's only during a drought that you get water down to the soil surface, and we've actually seen it stimulate vegetation and elevation gain. So these are cow sab and Mermentau vegetation cover charts, and so the red classes are the 80 to 100% cover, 68 to 80, so on and so forth. And so you can kind of see these increases in 2018 and 2022. You can see that it was, you know, more vegetation in 2011. Like, these Chenier Plain marshes are actually stimulated by drought and the low water that comes from that. And so, again, we need hydrologic restoration in those areas, and we need management plans that aim to stimulate vegetation, you know, by, you know, drawdown at the right time of year, if you know, the Gulf will allow. One cool thing in the vegetation data is that you've got a lot more. These charts are taking the entire vegetation database and looking at the number of observations per year by species, which is something I was curious about. And it's there. You know, you see an expansion of freshwater vegetation. Typha is that top left one. Chenoplectus, vines like Ipomea, ferns like Pholeptrus, tubers, Sagittaria has really taken off. Weedy species like alligator weed are on the rise. So that's kind of neat. You know, it's just kind of capturing the freshening effect. Saline species are kind of contracting. They're on the decline. I don't know that the species themselves are in decline. I wouldn't say that. We just don't find as much of them on the coast, except mangrove. Mangrove is still expanding. Mangrove is the one kind of in the middle. We do see more of it, but we see less. Iva, that's a salt tolerant shrub that you would see on shorelines. There's less of it. There's less. Symphiatricum is an aster that's salt tolerant. There's less of it. Batis, that's a succulent. You know, we don't have a lot of barrier island data, so we don't see a lot of succulents anyway, but it's gone from almost, well, it looks like just a few observations. It's probably just at one site. Lythrum has gone down. Chuncus romarianus has gone down. And to the right is Desticulus. I think that one's kind of interesting. It peaked during the 2000, or just after the 2011 drought, when things were still salty, and then has declined in recent years as it's freshened up. So I don't know, that's kind of neat. So in summary, kind of wrap it up, and then if you guys have questions, we can go back through any of this that you're interested in. But I would say it's changing fast, and we do capture that change coastwide. We've seen the recent sea level acceleration. We captured the response of elevation and vegetation and accretion and land change. It's all publicly available, thanks CPRA, and we rely on published research. So if any of this is interesting to you, if you're a student, researcher, get after it. You know, I'm kind of collecting things that I think are interesting. I'm not about to publish on all this stuff necessarily. And so if any aspect of this is intriguing, you should get on it, because, you know, and we almost need new textbooks at this point, and you could create that with a network like this, and do it soon. You know, the master plan cycle is rolling again. You know, we've just published our last one, but the discovery phase for the next one is basically the next 3 years. So the sooner research is published, the more impactful it will be. So go get it. And then just as practitioners, the coast that we're restoring is dynamic. The processes vary by region and marsh type. You got to understand the baseline. You got to understand the trends that, the sites that we're restoring are already changing. And so you have to capture those trends. You have to understand where you are. You can interpret individual values, but I would take advantage of the network, the robustness of the network, the fact that these sites have neighbors that are doing something similar, but maybe in a different phase of whatever the dominant process is, and kind of use the entire network when interpreting the data. So I guess that's it. That's kind of what I had. I thought it would take a lot longer, but that's what we did. So I hope you have questions. I'm happy to kind of go back through any of this stuff.
Yeah, Leanne, great presentation. I wanted to just tag on to one thing you said there at the end, that CRMS as a program is just incredibly useful to someone like myself who spends the majority of my time designing projects, and it's often CPRA funded projects. And as you can see, for everyone that in attendance, Leanne is kind of a guru in the whole CRMS program. And yeah, just we rely very heavily on it on the engineering and design side, to say the least. And I'm saying that with particular interest to some of the CPRA folks that I see on the attendees list, like I saw Eric Whitney, Kristen Ramsey, some others there. So thanks, CPRA, for helping us be able to engineer CPRA projects better. I'm looking at the chat. I'm seeing none so far, but I'm like you, Leanne. I definitely want to encourage the group to ask away. As I said earlier, I don't know if anyone's joined in since. In the event of any questions, feel free to put them into the chat box and we'll be happy to field them. Let's see who's here. I guess y'all all ask again.
Experts, they got it.
What's that?
They got it all figured out.
Oh yeah, I guess so. Okay, well, I guess, Leanne, we can go ahead and wrap up. I appreciate it, Eric. For anyone that's interested in reviewing this later, we are in the process of recording. This recording will be made available publicly. And please stay tuned for the rest of the Coastal Industry Week events. The next webinar is this same time tomorrow, so noon Central. And we've got Eric White and Krista Jankowski from our Planning and Research Division here at CPRA are going to be talking about the Master Plan Data Viewer. All right, and yeah, Kristen, I see your message. We'll be able to get that to you. All right, everyone, really appreciate it. We're going to go ahead and conclude. See y'all tomorrow.
Thanks, everybody.